Hello, welcome to today's lesson. This is Math is Fun with Mama Joy. And in today's episode, we will be seeing becoming a math ninja. Yes, a math ninja. So for lesson 2, we are developing algebraic expressions from word problems. So our previous lessons, we saw what algebra was and what algebraic expression was. And today we'll be developing our own algebraic expressions from a given word problem. So now let's understand word problem. So what is word problem? Word problems are simple math exercises in which the information is presented in words or text rather than numbers. So in word problem, we don't see numbers like 2 plus 2 directly. We see it in a text form. So this is why you've been taught how to write words, how to write numbers to words and words to numbers. So something like, let's say, let me get my pen. Let's say thousand. Don't mind my handwriting. So 1,000. It won't appear like this in word problem. Instead, you see. So let's just go mathematical. You see 1,000. So 1,000 in words. Yeah, my handwriting is bad. So you see 1,000 in words. So this is how word problem is going to appear. So instead of figures as in 1000, you see it in words 1,000. Okay. So how do we tackle word problems? So the first thing you have to do is to read the question or the problem carefully. Read the question or the problem carefully. Remember every word in the sentence. Remember every word in the sentence matters. So every single word in a sentence matters. Even the dots, the commas, the punctuations matter. So the last step is for you to gather your weapon. So we are tackling this mathematics like a ninja. So our weapons for this particular word problem solution is numbers, variables, and signs of operations. So as we learned in the previous lesson that algebraic expression is a combination of numbers, variables, and signs of operations. So these are our weapons to tackle this math problem. So we are going to combine all these things together. So we are going to combine numbers, variables, and signs of operation. So this is what we'll use to solve our word problem. Okay, so this is Sensei. Sensei is telling us how to tackle to tackle more tricky missions. So if you find more difficult tasks, these are the things you need to remember. So we did signs of operations and we talked about the 4 basic signs of operation in mathematics in our previous lesson. So I keep on making reference to our previous lesson. If you've not watched that or studied with us on the first lesson, I think you should go back and then see where we started from. So for signs of operations, we have addition, subtraction, multiplication, and division. So we already know what addition is, what subtraction, what multiplication is, and what division is. But now we are doing word problems. So this is more of English language than mathematics. So if you don't understand mathematical English, it's be difficult for you to solve this word problems. So first of all, addition. Sensei is saying that if you see the sum of increase by plus addition to added to or more than, when you see these 5 things, they mean we would have to add. So you have to introduce your plus sign there. So you introduce your plus sign there. Sensei is also saying that when you see subtraction, you would see this other word there. So there are 5 words you might see which means subtraction. So the first one you can see is the difference of, decreased by, minus, subtracted from, less than. So when you see these 5 words, you just have to introduce your subtraction sign. Then further on, Sensei is saying if you see the product of multiplied by or times in a word problem, then you would have to introduce your multiplication sign. So our times sign. Then finally, if you see the quotient of, divided by, or the ratio of, this is where we introduce our division sign. So these are the 4 basic signs of operations. This Sensei has added more synonyms that will help us solve more tricky missions. Don't forget, missions are not easy tasks, but with Sensei's help, we'll tackle it. So on to the next slide. This is Anib in the slide. Her name is Anib. Anib is, okay, so we want to write, Anib is 11 years actually. How do we write 10 more than Anib's age? So in this case, Anib is 11 years. So her name is Anib. She's 11 years old. So we want to see how to write 10 more than Anib's age. Sensei said in the previous slide that more than means to add, right? So yeah, we need our plus here. That is our first weapon. And Anib is 11 years old now, as we said. So 10 more than Anib's age will be Anib's age now plus 10. And how old is Anib now? 11. So 11 plus 10 will give us Anib's age in 10 years, or 10 more than Anib's age. Okay, so Anib also wants to know Sensei's age. We know Sensei should be very, very old, and Sensei doesn't want to tell Anib his age. So Anib wants to know Sensei's age decreased by 5. So Sensei's age, but Sensei will not tell Anib his age. So what should Anib do right now? But this is mathematics, so something can be done. So this is where variable comes to play. Remember from our previous lesson, we said variables are used to present a number that is unknown. Yeah, Sensei's age is unknown. We don't know Sensei's age. Sensei can be just like Avatar, 10 million years. So we choose a variable, maybe n. You can choose any other variable you want. So say n to represent Sensei's age. So now we can re-modify the sentence. So now Sensei's age, we say is n now, right? Decrease by 5. Sensei told us previously that anywhere we see decrease by 5, anywhere we see decrease, we should subtract. So decrease by 5. So that is how come we get this. N minus 5, which is Sensei's age minus 5. So minus 5 means take away 5. So we are taking away 5 from Sensei's age. Okay. So why? So this is Anib's brother who was listening to the conversation, and now he comes to ask, why was the answer n minus 5 and not 5 minus n? So some of you will be wondering, why wasn't it 5 minus n? Okay, we said Sensei's age decreased by 5. It means that 5 is being subtracted from. We are taking 5 away from Sensei's age. So meaning Sensei's age is there, then we are removing 5 out of it. So that is n, remove 5. You get it? So n, Sensei's age, remove 5. You remove 5. So it can't be 5 minus n. We can't remove Sensei's age from 5. Because Sensei might be 1,000 years old then. Okay. So this is a question. Anib is actually covering the main question. So what is here is math. So Anib is asking Sensei, but Sensei, why use math? Why use math? If we can describe things in words, so there is an in here. If we can describe things in words, so I know some of you can be confused about this, that since we can describe things in words, why then should we do mathematics? Now Sensei, the wise man, is saying one of the many reasons we use math is because mathematics is more precise and easier to work with than words are. So taking the case as Anib asking for Sensei's age in 10 years or decreasing Sensei's age by 5. In English sense, nothing can be done to it. But now, because of mathematics, Anib is able to construct something to show Sensei's age. So the higher you get, you'll be able to estimate Sensei's age and replace that n by a number which we think will best suit Sensei. So in this case, the mathematics makes it easier for us to work with some problems. So with this, we are able to delve deeper to find so this will make Anib start thinking and start being on the lookout to see what Sensei's age is. So in future, if she's able to get a clue as to how old Sensei's age is, then she'll just replace the n by maybe 80 and then get the answer. But if she leaves that in a sentence form, nothing can be done. You thinking about the calculation in your head is mathematics. So Sensei says I'm 80 years old. Oh, okay, Sensei is 80 years, so that's 80 minus 5. You've done mathematics. So mathematics is more precise and easier to work with than words are. So that is why mathematics is far, far easier than any other subject in the world. Okay. This is a question you should keep thinking about as you dig deeper into this mission of being a math ninja. Okay, so now let's see a few more examples to get you ready to be the math ninja you want to be. So there's an example. Find 3 more than the number. So this is a question. Find 3 more than the number. So I'm like, what number? Like, what is the number? So because I'm asking myself, what is the number becomes unknown here. So what comes into your mind? Variable. So we replace that thing we don't know, that unknown thing, with a variable. Then 3 more than the number becomes, that's how you find 3 more than the number. So x is the number plus 3. So the number is there. More than means plus. More than means plus. So x is the number now. So we are replacing the number with x plus 3. So you see this, you would ask again, why didn't 3 come before x? For addition, it can be pardoned, but for subtraction, 3 can't come before x because that is not what they are saying. This is because 3 has been added to some number. So the number was there on its own. So this is the number here. The number was here, and you decided to come and add 3 to it. So who was there first? The number, of course. So in this case, you can't come and add the number to 3 because 3 wasn't there. The number was there and 3 was added to it. So remember when we were calculating Sensei's age, it was n minus 5. So the unknown comes first. Okay, next slide. So how do we find the product of 8 and k? Remember, product means we multiply. 8 times k becomes the answer because it said find the product of 8 and k. So in multiplication, we can rewrite 8 times k as 8k. So this is what Sensei is telling you only in multiplication. So in multiplication, we can write 8 times k as 8k. So when you see 5k likes on Instagram and 5k likes on Facebook, it means 5 times k. K means 1,000 in English sense. So 8 times k becomes 8 times k becomes 8k in mathematics. So that's why they simply write 8k, which is 8 times 1,000, like 8 times 1,000. That's for Facebook, but this is Sensei's class. So Sensei is telling you, don't forget it applies to only multiplication. Don't do this for addition. So say you have 8 plus k. Never write 8k. No. It only applies to multiplication. So this is wrong. So 8 plus k is not 8k. It's only 8 times k. So if I have 5 times a, the answer becomes 5a. 3 times a, the answer becomes 3a. But 3 plus a is 3 plus a, nothing else. So I know you've noted this. Now, how do we get twice the sum of m and n? So this is another problem, another word problem. So the first thing you have to do is to read the problem carefully. How do we get twice the sum of m and n? So this is the word problem. Twice the sum of m and n. So after reading the question, the problem carefully, in mathematics, twice simply means 2 times. So I have once, twice, thrice, yeah, and so on and so forth. So in math, twice simply means 2 times. That is 2 times. Now take note of the. So twice the sum of m and n. So sum of m and n. The sum of m and n means m plus n. We are adding m and n together. So since they said twice the sum of m and n, twice. So it means 2 times, but we have to get the sum of m and n first. Then when we get the answer, we multiply by 2. So in this case, we introduce our bracket here. So we have 2 times m plus n. So 2 times m plus n. So the 2 times means the twice. There we open our bracket, the sum of m and n, we do the summation inside the bracket, we close the bracket. Simple as Fruit Ninja, playing a Fruit Ninja game. Okay, so Sensei is telling us we just have one more and then we are good to go. Let's see what Sensei has for us. 2 times the product of a and b divided by 5. So as we learned before, 2 times means 2 times. The product of a and b will give us product. Since it's a product means multiplication. So 2 times So let's take one after the other. 2 times the product of, so this is the product of A and B, divided by 5. Divided by 5. So this is what we get. So don't forget, since it said A times B, since it said 5 times 2 times K or 5 times K in multiplication, so A times B is AB. So definitely 2 times AB will be 2AB. So that's how come we've gotten this here. So 2 times A times B is 2AB divided by 5. So don't worry if you don't get this. We'll brush it up in our fourth lesson, which is multiplication and division of algebraic expression. So now you are ready for your first mission. You can do this. There may be a few difficult problems. Don't forget your weapons. Remember, every problem has a solution. I'll be there if you need me. Say Sensei. For all your missions that you'll be tackling, you would have to write them down in your notebook. So you should get a notebook for this lesson. Then work them out there. And when you're done, take a shot of it and then submit it. And I'll mark and send you your scores. So the first mission, write the algebraic expressions for the following: sum of x and twice y. So I think this, we're supposed to subtract. So let me correct this quickly. Subtract 4 from y. Then the third one, twice the sum of m and n. The fourth one, b is decreased by twice a. So this, I should have written it in, let me just erase it. So this should be 4 because we are doing word problems here. So subtract 4 from y. Then the third one, twice the sum of m and n. Then b is decreased by twice a. So your final mission, write the algebraic expressions for the following: 1, 2 times the product of x and y divided by 3. 2, x more than 2/3 of y. 3, half a number decreased by 3. 4, 4 times x less the sum of y and 6. The last one is double the sum of a and m. Congratulations, you are now a math ninja. So I want you to design a project. So a ninja always practices so as not to lose his skills, right? And I've always told you to practice, practice, and practice. So you're a math ninja now. But what other things do you know about ninjas? What do ninjas do? So I want you to design 3 things. Let it be colorful. Just design. You can use your paint application. You can use a crayon and a cardboard. You can use an A4 paper. I just want a colorful design of 3 things you know about ninjas. Then send it to me. I'll post it on our platform. Thanks for watching and listening. I hope you enjoy the class. Send me your feedback and let me know. If you don't understand anything, feel free to contact me and I'll be there to help. Bye bye.